The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, welcome to our webinar for point-to-point PTP 550, which is our latest product line over here. I hope the webinar is clear and you're able to hear my voice clearly. Okay, so to get started, so today's agenda that we're going to cover is mainly going to be the overall PTP portfolio, the introduction of PTP 550, some of the key highlight features of the PTP 550. Also, then we're going to review the PTP 670, which is our Tier 1 product versus the PTP 550. Next, we're going to discuss a little bit about product launches, followed by a summary, and then provide you links and access to more information regarding these products. All right, let's get started. So this is our PTP portfolio that we have over here. On the left, we have the PTP 450, which has a max throughput of around 200 plus Mbps, which operates in the 903 and 5 gigahertz spectrum. Next, we have the PTP 450i. The key highlight features for this is 300 plus Mbps. It supports ARQ and it has 8x hash-lock. So we do have a PTP 450i version which is 8x and hash-lock compliant. Next is the PTP 550. That is our latest flagship product. So the main three key features for this is the high throughput is about 1.4 plus gigabits per second. It supports channel bonding and it also supports DSO. The next one is the PTP 670, which is 450 plus Mbps. It supports HCMP and it supports DSO. So if you kind of map out the PTP portfolio for Cambium networks, we kind of get this kind of chart that we have over here. On the far right top, we have the PTP 670, which has a lot of features richness with respect to security, with respect to channel bandwidth, with respect to a lot of minute details which make it an exceptional product. Whereas towards the lower left, we have the PTP 550, which has a little less richness in features, but definitely in comparison with the price, kind of keeps in line with the PTP portfolio. Next, we have another way to depict the same four product lines. So on the top left side, we have the PTP 550, which is mainly built for speed. So it has a 1.4 gigabits per second. That's where this fits in, and then the remaining of the products kind of align on this chart this way. Let's focus a little bit about the vertical markets that the PTP 550 is going to cover. Some of the main ones are going to be wireless internet service providers or WISPs, followed by utilities and public safety. We'll go into a little bit more detail regarding this. So the first one is enterprise service providers and private sectors, followed by oil and mining, and then video surveillance and disaster recovery for public safety. The PTP 550, this is the connectorized version that we have. So it comes in two flavors, the PTP 550 connectorized and the integrated. The picture that we have over here is the integrated one. The frequency band that it supports is from the 5150 to 5950. So basically it covers all the FCC regulations, the 5152, 54 and 58 bands. It supports 20, 40 and 80 megahertz channels. So it's actually 2 times 2, 20, 40, 80. We will get into it a little bit later on. So spectral efficiency is about 8.75 bits per hertz. With respect to interface, it has two main interfaces. One is the Gigabit Ethernet port, which is also your power and data. And we also have a SFP port. The reasoning for SFP is a lot of commercial and residential apartment complex, especially which are being built newly, have SFP or fiber connectivity throughout the building, because the demand for internet is only going to increase going forward. City planners and developers are already taking that into account and adding fiber networks within their building to support it in 5 years or 10 years or anywhere down the line, because they know people are going to require more bandwidth along the way. Next one, the adaptive modulation. So the PTP 550 supports from QPSK all the way to 256 QAM. The aggregate throughput is about 1.36 gigabits per second. The power output is about 27 dBm at BPSK and 23 dBm at 256 QAM. The integrated panel is a 23 dBi dish. The latency is about 4 to 5 milliseconds in one direction, and it has a IP66-67 housing. Some of the key features that the PTP 550 has is DSO, that basically scans and hops to the next best channel given there is some interference in the current channel. It supports near line of sight and line of sight applications, and it also supports channel bonding, which we'll get into a little bit later on. This is the adaptive modulation, which is hitless for the PTP 550. So basically, as you have better interference, as you have worse interference, your MCS rate goes down, and as your interference kind of decreases, you can kind of level up your modulation scheme from 5 to maybe 9 along the way. This is the antenna pattern for the PTP 550. The antenna gain is 23 dBi. Antenna beam width is about 8 degrees, and the dimension is 12 inches by 12 inches. The PTP 550 is IP66-67 housing. Basically, what it means is it has protection against solar radiation, hurricane speed winds, dust and water protection, and harsh weather conditions. So the below temperature kind of shows from -60 all the way to 140 is the range of the radio that it can support, and the green slab indicates the general temperature of any lot of places on Earth. So the majority of the weather conditions is going to be within the green belt, but then the radio supports all the red marks indicated below. This is the 5 gigahertz spectrum of how the PTP 550 radio capacity works. In the diagram, we can kind of see we have the 5.1 band, 5.2 band, 5.4, and 5.8. Each band is about 100 meg. So 5.1 has 100 meg, and then the 5.2 has 100 megahertz. The 5.4 has 255, but that 5.4 will also have the DFS built into it, and the 5.8 is the 125 megahertz. So this is a really neat feature that the PTP 550 has. It's called channel bonding. So basically, what channel bonding is in the 550 we have two radios that are built into the same into the same housing, which can operate independently of each other. You can select channel A as 20 megahertz and then channel B as 40 megahertz, or you can kind of mix and match according to your needs. This is a really neat feature because it kind of plays into real world scenarios where you might have one good channel and then another channel which is kind of really has a lot of interference built into it. So in this example, maybe if you have one 80 meg channel and then maybe a 20 meg channel, so you mainly have one clean channel, so your average throughput is around 850 plus Mbps. So you have two good clean channels, your throughput is going to be about 1.4 gigabits per second. So you can kind of see how this plays into different scenarios where you try to use. We have just thought of two use cases to just give you an example of how you can start using it in different scenarios. For example, let's say you set one channel as DFS and channel A as DFS and channel B as non-DFS. So what this means is your channel A is set somewhere in the 5.4 band, and let's say the channel B is set in the 5.8 band. Especially now, let's say both of them are 20 meg, 40 meg each. So especially now, if your channel A gets hit by DFS, so you have to back off the channel A. So what actually happens is all the traffic from channel A gets rerouted to channel B. So and the channel A kind of backs off till the radar detection is gone, but then it comes back up. During that time, all the traffic flows through channel B. So the main idea being, even though your throughput gets hit by a certain percentage, your link never drops. That's the main advantage of using channel bonding. And then once the DFS, the detection is done and there's no radar, all the data gets again forwarded back or gets rerouted back to channel A and channel B. So this way you might have a temporary link efficient link drop for a few minutes given how long it takes, but then you always bounce back automatically without any problem. Another use case for the channel bonding would be to use aggressive and resilient settings. So let's say you set channel A in a very aggressive channel. like a 40 megahertz in a 5/8 band, which is generally crowded, so it's really hard to get a clean 40 meg channel. So you can kind of set an aggressive 40 megahertz channel, and then you can set a channel B in a resilient 20 megahertz channel, so you know for sure in your 5/1 band you have 20 megahertz to spare. So the advantage of this is because you're sure of the 5/1 band being resilient, you always have you always can be assured that you always have some resilient link on the side, whereas your channel A can be aggressive and try to pursue higher bandwidths if required. And the channel sizes can be set independently, as I mentioned earlier, so it doesn't have to be 20/40. It can be any of the combinations of 20/40/80 on either side. Also, the one more thing is the modulation scheme present here is different. So, for example, if you're in an aggressive network on a 40 meg channel, you could be using QPSK. I'm just giving an example because of really tough interference. Whereas your resilient network with a 20 meg channel, you can be at 64 QAM, right? So you can have independent modulation schemes on its own, and they're not dependent on each other. Right. Let's focus on DSO. So DSO is mainly dynamic spectrum optimization. This is with respect to the online spectrum analyzer that we have. So in our radio, we have a dedicated chipset that's mainly built for online spectrum analyzing. And this always has the latest information of how the network is how the radio interference is performing, which always continuously scans, and it gives you information for that. You can use it for proactively planning channels, proactively rerouting or remodeling channels based on your needs. So it scans all the bands from 5/1 to 5/9. You can save the data and all that fun stuff. The main advantage of DSO is you can set a certain threshold or interference level. So if your RX receiver sensitivity drops below a certain level, you can set it to trigger a DSO. So DSO basically what it does is it scans for across the board for the next best channel, given you hit this trigger point. So in that case, all the data moves from channel A to channel B, or whichever channel wants to move out. All the data gets transferred to the other channel. So the channel that wants to do DSO then searches for the next best channel. Once it finds it, it does the handshake with the other side, with the remote side, and then once the negotiation is done, all the data moves back or comes back to channel B, and then both the channels are sending data and receiving data at that time. So this is a really neat application that a lot of times, sometimes you may just get hit by interference level for some time. So you can also set the timer up to which you want the interference level to be hit. So you would want to say, oh, I want to check for interference every 30 minutes, or you want to keep it at every 6 hours, or you want to keep it at every 5 minutes. It's up to you. So you can set the configuration in that sense. So it also supports PTP sync. Basically, PTP sync is if you have two radio towers which are close enough, but are on a slightly different angle, and if they're using the same frequency, because of the TX and RX mismatch, there's going to be some duty cycle that gets overlapped, and that's going to cause cross interference with each of the radios, and that's going to eventually increase packet loss, and then you reduce your actual throughput along the way. So the PTP 550 supports the PTP sync that will align so that you can align your transmit and receive cycles so that there's no interference from the other radios. Some of the key security features that the PTP 550 have is the AES 128 key encryption protocol, which is already there. We have multi-level authentication. Each software is tested against latest known attacks with the industry standard tool. We do prevent unauthorized software modifications which cannot be loaded at all, and we encrypt some of the sensitive parameters and the configuration parts. So this is the uplink downlink ratio. The uplink downlink ratio basically means so the time in a frame duration you have the uplink slot and then the downlink slot, and then you use that for burst direction. You could currently we do support 50/50 solution. We do support the 70/30 configuration and the 75/25. Of course, on the other side, it's going to be the reverse. So this is the throughput that you're going to get. So let's do a quick comparison on the PTP 670 versus PTP 550 that we have here. Firstly, you can kind of see the frequency band supported for the PTP 670 is higher than the 550. So the PTP 670 supports the 4.9 or the public safety, whereas the 550 does not. The max throughput for PTP 670 is 450 plus Mbps, whereas the PTP 550 is for 1.4 gigabits per second. Spectral efficiency for the PTP 670 is 10.1 bits per hertz, whereas the 550 is slightly lower for 8.75. The PTP 670 supports HCMP or multi-point. So basically, you can connect up to 8 remote to one HCMP to one PTP 670 master. So you can kind of use it as a multi-point mode, whereas the PTP 550 cannot support that. Both the radios support some form of DSO, and PTP 670 supports the AES 128 and 256, whereas the 550 just supports the 128. The PTP 670 supports 1588 timer edge sync key, whereas the 550 cannot. The antenna gain for both the integrated versions is 23 dBi. We do not support jumbo frame for the 550, whereas the 670 supports up to 9600 bytes, and TDD sync is supported, as I mentioned earlier. Quick summary to kind of go over all the broad areas and broad channels. One is the PTP 550 is 1.4 gigabits capacity with using two 80 meg channels. This is our headline throughput rate. This is not PHY. This is using iPerf. We did test it out, and this is the number that we got. Secondly, we do support asymmetric non-adjacent channel bonding, which means you have two channels which are not the same size, which are not on the same band, but are like, for example, 5.1, 5.8, which each have 20 and 40 megahertz channel. We support asymmetric modulation because each band has its own interference ratio. Each band is not the same, so we do support asymmetric modulation for each of the channels independent of each other. We do the PTP 550 supports or has a SFP port, which is the fiber port, which can be used for different applications. So, for example, you can plug in your SFP for a gig capacity and then shoot out 1 gig from your radio, so it should not be a problem. The PTP 550 supports ARQ protocol. This ensures there is no packet loss along the way, and then due to ACS, so it ensures that no packets are dropped between the two radios. The PTP 550 has a small form factor and metal enclosure. This is a really important physical attribute of the product, because it's so small and it's easier and light to carry that it's much easier to carry it up the tower and to install because of the small form factor. And having a metal enclosure always helps, because especially if you're setting it up in winter conditions or during winter or summer, where sometimes temperatures can be brutal, it's much safer to use a metal versus other forms. Some of the key important dates, we did launch the product on October 11th, and we are accepting pre-orders, and we start shipping, or our order fulfillment shipping begins around November 28th. So these are the important dates. For more information, please visit our cambiumnetworks.com website. We do have a lot more information with respect to spec and any of the other features as well. This webinar is being recorded, and it will be posted in the community webpage. If you're not already on community, please do log in and register. We do have a knowledge section base which kind of goes over all of these webinars, and everything is going to be posted over there probably by end of today. The forum also posts different kinds of questions. So if you have a really specific question with any of the point-to-point products, you can kind of post there, and our team of engineers, including myself, will be there, and we'll be definitely able to answer your questions quickly. So also, please keep in touch. Please review the knowledge base and submit any development ideas that you have. And also follow us on social media. And with that, I will be taking some of the questions. I think we have a few questions here. Bear with me for a minute as I scan through some of them. Okay, here's a question from Jeff. Can you bond channels from different bands within the 5 gig? Yes, you can. So you can use a 5.1 and a 5.8 band that you can. Okay. Next one. Can we unlock the region on the PTP 550 EU version like we do currently with the PTP 450i through support? That's a good question. And as of right now, we do not support it, but going forward, we definitely have it in mind, but I'm not sure by when it's going to be there. Okay, I have next question. How does it handle different rules in different bands? That's a good question. So Jeff, the way it works is each radio has its own. You can kind of see it as like each radio operates on its own. So it handles the TX power separately. It handles the RX sensitivity separately. It handles so each radio it's basically two radios built into one. So all the TX power, all the receiver sensitivity, all the modulation scheme are all independent of each other. The only thing that is common is the two interfaces towards the end when the data comes out is kind of linked together. So we have internally all that is two separate radios. So it also takes into account the rules for each one. So I know the 5.8 has a lot more flexibility with respect to the TX power, whereas the 5.1, 5.2, and 5.4 are kind of restricted in some areas. So it does support that. Okay, next question. So there's a question on the PTP 550. So the PTP 550 comes in a kit form. Basically, it only comes in a kit form. So basically, the contents of the radios, so the contents of the kits are, it's going to have one radio, it's going to have one AC power injector, it's going to have a mounting bracket, a tilt bracket. It is going to have a line cord. It's either going to be a US or EU based line cord. I think that answers that question. Okay. What is the maximum frame size on the PTP 550? Right now, the maximum frame size that it can support is 1700, but we do plan to increase it later on. I have another question, which is, does the PTP support E1? Right now, it does not. It does not support E1. Can we order demo kits and what limitations are there in? Okay, so you can order demo kits. We are accepting pre-orders. With respect to limitations, DSO. Sorry, that's a different question. With respect to limitations, I'm not sure what kind of limitations you're talking about. I'm not sure for that. But you can order demo kits from today. DSO is a good solution. Lionel, I'm not sure what your question is. You said DSO is one good solution if DASF. I don't know what DASF stands for. Scrolling down for more questions. Okay, there's a question. Does the PTP 550 link up with the PTP 650 or 670? No, it cannot. It's a different chipset. It's the way it's built is different. The protocols are different. So the PTP 550 cannot link up with the 670 or the 650. Oh. Okay, I understand your question, Lionel. Okay, so DSO is one good solution if it's the radar or because of the DFS. So basically, yes, a lot of customers are planning to use it in this format where you have one channel which is DFS channel, which is the 5.4 band, and the other channel is going to be like a 5.8 or a 5.1, which is not compliant by the DFS. So even if you get hit by the DFS, you have to back off. That radio has to shut down for some certain amount of time till the radar detection is gone. So in that case, for that time, what you can do is you can transfer all your channel to the other channel, let's say the 5.8 channel, so that even though you have limited capacity, your link never goes down. So even though your customers might see a hit in its throughput capacity for a few minutes, but they would never experience like a link drop, which is the worst case scenario for this one. So yeah, so DSO also fits in for the DFS solution. There's another question: when do you expect them to arrive in the US? So our order fulfillment begins around November 28th, give or take 4 weeks, or maybe less than that. You can say 4 weeks for them to ship or freight them into the US for our local distributors. I think those are all the questions I have. I think I've answered all of them. I'm going to wait maybe a couple of minutes for a few more questions that you have, and then we can go from there. Right. There's a question on the chipset that if this is a Wi-Fi based chipset, and it is a Wi-Fi based chipset. Okay. I think that's all the questions that we have for this session. Thank you very much for attending. I have recorded this session and I'll be posting it online. Please visit our community page for more information and to get access to this PDF or the deck and the video one. Okay. Thank you so much.